The magnificent forests of Quebec are rich in natural resources. We are privileged, but also aware that these resources don't last forever. For this reason, we have been working hard for many years to protect and improve them. Abiding by the strict regulations of Natural Resources Canada, we use the natural technique of regeneration. All of our logging activities are done in compliance with the biological diversity of our forests. Actually, we foster selection cutting. Our technicians take great care in selecting the mature trees to be removed, allowing immature trees to grow strong. This simple and efficient approach allows us both to remove high-grade trees and improve the growing conditions of the remaining ones. The quality of our raw material and wood processing plants allows the province of Quebec to offer a wide range of high-quality products. In fact, our state-of-the-art plants, equipped with advanced technology machinery, ensure high-volume production as well as highly accurate products. Computerized systems contribute to maximize the use of raw material while optimizing cutting accuracy. Traditional plants meet more specific requirements. Since they are more flexible, they can provide a more customized product. For high volume, as well as limited orders, Quebec wood producers have a common objective: deliver a product that will satisfy your requirements. In a few minutes, you'll see how we determine the grade of hardwoods. Hardwoods are graded on the appearance and yield of clearwood in each piece, whereas a softwood board is graded on its appearance and strength as a whole piece. Here's how we describe a piece of wood. In our industry, all lengths under 12 inches exceeding the exact length of a piece are considered as overlengths. Regular lengths are 4 feet to 16 feet in multiples of 1 foot. Thicknesses under 1 inch are expressed as follows: 3/8 of an inch, 1/2 inch, 5/8 of an inch, and 3/4 inches. Thicknesses 1 inch and above are usually expressed in fractions of an inch, such as shown in the following table. These sizes are characterized by what we call rough nominal thickness. This is how thick a piece should be cut. However, an allowance of 1/16 of an inch to 1/8 of an inch thick must be made to all pieces in case of shrinkage after drying. Before determining the grade of a piece, it is necessary to calculate its surface measure, SM. 1 SM is equivalent to 1 square foot surface, or 12 inches by 1 inch. Since widths are varied in hardwood sawing, only the piece's actual width should be considered in calculating the SM. The SN of this piece is therefore obtained by multiplying its width by its length and dividing by the basic measure. The 4-inch overlength is not considered in SM calculation. It will be used when calculating the units contained in a cutting. This is what may make a piece grade 1 common instead of grade 2 common. We therefore obtain a piece 6 1/4 inch wide, multiplied by 8 feet long, divided by the basic measure 12. We then have 50 divided by 12 for a total of 4.16 SM, or 4 SM. In grading, values higher than 0.5 will be rounded up. 4.53 SM equals 5 SM. And values equal to or under 0.5 will be rounded down. 4.5 SM or 4.16 SM equals 4 SM. In tallying, values equal to half will be alternately marked up and down. BM, which stands for board measure, is used to determine the volume of a piece. One board measure equals a piece 1 inch thick by 1 foot wide by 1 foot long, or 1 inch by 12 inches by 1 foot. Since widths are varied in hardwood sawing, the piece's nominal width should be considered in board measure, BM calculation. This implies that the allowance of 1/16 of an inch to 1/8 of an inch made in case of shrinkage after drying is not included in the BM measurement. For example, if we have a piece 1 1/2 inch thick by 6 inches wide by 8 feet long, we divide by the basic measure 12 and we obtain 72/12, that is 6 board measures, 6 BM. As in SM, overlength will not be taken into consideration. Only whole numbers are accepted in BM calculation. BM can be easily obtained by multiplying the SM by the thickness of the piece. However, it is recommended to use the BM standard formula to be able to find the exact BM of a piece, as the results may vary due to overlength. Before we get into hardwood grades, it is essential to know some of the definitions and characteristics of wood. Air-dried lumber. Dried by exposure to air, usually in the yard without artificial heat. Kiln-dried lumber. Dried in a kiln with the use of artificial heat. Greenwood, freshly sawed wood. Decay. A decomposition of wood substance by fungi. Abnormal stain. Any change of color caused by the growth of fungi on or inside a piece, usually reflected by a thin black line. Discoloration. Change of color due to overexposure of logs to sunlight. Split. A separation of the wood due to the tearing apart of the wood cells. Wane. Bark or lack of wood. Warp. Any variation from a true or plane surface, including bow, crook, cup, and twist, or any combination thereof. Season checks. A separation of the wood normally occurring across or through the rings of annual growth and usually as a result of seasoning. Ordinary season checks are no longer permitted in clear cuttings unless they disappear at minimum plane thickness. In sound cuttings, checks are usually permitted only if they do not impair the strength of the cuttings. Pith, the small soft core in the structural center of a log. Encased knot, a knot which is not intergrown with the growth rings of the surrounding wood. Sound knot, a firm knot which contains no bark or decay. Bark pocket, a bark-filled blemish on the surface of a board which does not extend to the edge. Shake, a separation between the rings of annual growth. Mineral streaks and spots. Dark color stains are usually found in hard maples or basswood. Mineral streaks and spots, or streaks and spots of similar nature, are permitted in clear cuttings. However, a number of species, such as hard maple 1 and 2 and basswood keystock, are submitted to limiting provisions of stains on surface. Bark-filled mineral streaks are prohibited in clear cuttings. A cutting is a portion of a board taken between defects parallel to the axis of the piece. It cannot be diagonal. The yield of a piece is based on the percentage of clear cutting units contained in it. To calculate this percentage quickly, it should be converted into twelfths and applied directly to the SM. The SM is divided into 12 equal portions on its width, which gives 12 portions of 1 inch wide by 1 foot long, called cutting units. The number of cutting units contained in a piece will be used to estimate the percentage yield of clearwood. Theoretically, 1 SM should contain 12 units. The grade of a piece is determined according to the required percentage. The yield of a piece is calculated by multiplying the SM by the factor corresponding to this percentage. For example, to calculate the SM of a 12-inch by 9-foot board, we multiply 12 inches by 9 feet and we divide by 12. We then obtain a total of 9 SM. The required yield for this piece is 50%. The number of units required per SM is 6 out of 12, that is, 6 as the factor. The number of units required in that piece is obtained by multiplying 9 SM by factor 6, which gives 54 units. Since the dimensions of cuttings may vary between pieces, the number of units contained in each piece will be calculated by multiplying the cutting's full width by its full length. Let's calculate the SM of the piece first. 9 3/8 of an inch multiplied by 16 feet divided by 12 equals 12.5 SM. This piece is measured as a piece 12 SM when grade and yield are to be determined. Now let's calculate the number of units contained in each cutting. Overlength in units can make a piece grade higher, especially in the case of pieces showing wane or equivalent defects on their sides. This common practice is to preserve the dimension of 2-foot cuttings in commons. Any defect included in the overlength will not be considered. Only the units will matter. There are 2 categories of cuttings: clear cuttings and sound cuttings. Clear cuttings are free from defects. Unless otherwise specified, they are graded from the poorest face. Reverse must be sound. In sound cuttings, 4 defects are not permitted: wane, pith, rot, and shake. However, other defects are admitted without limits: sound knots, bird pecks, abnormal stain, season checks that do not reduce the strength of cuttings, streaks, or other similar defects, and pinworm holes, 1 1/16 of an inch. Some others are admitted with restrictions: 2 1/4-inch holes, or 1 1/2-inch hole per 12 cutting units, or 1 1/4-inch hole if less than 12 units. Any small unsound defect, such as decay or a knot containing bark, will be replaced by a hole. Unless otherwise specified, the face with the lesser clear cutting units becomes the grading face. It is also called the bad or poor face. Clear cutting units are calculated on each face. The number and dimensions of cuttings are to be considered for each grade. Remember that the face with the lowest grade is automatically the grading face. For a piece to fall into a specific grade, it should have the dimensions required by that grade. A piece graded FAS 1 face should be 8 feet to 16 feet long and at least 6 inches wide. In FAS grades, pieces are graded from the poorest face, and in FAS 1 face, they are graded from the better face. A piece graded Select should be 6 feet to 16 feet long and at least 4 inches wide. In Select grades, pieces are graded from the better face. A piece graded Common should be 4 feet to 16 feet long and at least 3 inches wide. In common grades, pieces are graded from the poorest face. Sawed pieces may end up with a width under the width required by a specific grade. In every grade, the minimum width required for pieces may admit up to 1/4 of an inch scant, provided that it does not exceed 10% in volume. FAS. 6 inches required. 5 3/4 of an inch permitted. Select. 4 inches required. 3 3/4 of an inch permitted. Commons. 3 inches required. 2 3/4 of an inch permitted. The following is the required yield for each grade. For a piece graded FAS, FAS1 face, and Select face, the required yield is 83 1/3%. The piece should be 4 SM and over and have a factor of 10 units per SM. For a piece graded Select with 2 and 3 SM, the required yield is 91 2/3% on Select face, and the factor is 11 units per SM. For a piece graded 1 common with 3 SM and over, the required yield is 66 2/3%, and there should be 8 units per SM. For a piece graded 1 common with smaller SM, the required yield is 75%, and there should be 9 units per SM for a piece 2 SM. And for a piece 1 SM, the required yield is 100% on both faces. For a piece graded 2A common, the required yield for pieces 2 SM and over is 50%, with 6 units per SM. For pieces 1 SM, the required yield is 66 2/3% with 8 units. The 2B common grade requires sound rather than clear sound. For a piece graded 3A common with 2 SM and over, the required yield is 33 1/3% with 4 units per SM. For smaller pieces with 1 SM, the required yield is 50% with a factor of 6. The 3B common grade requires 25% sound yield and 3 units per SM for pieces 1 SM and over. Here's the minimum cutting in each grade. In FAS, FAS1 face, and Select face, the minimum cutting is 3 inches by 7 feet or 4 inches by 5 feet. In 1 common, the minimum cutting is 3 inches by 3 feet or 4 inches by 2 feet. In 2A, 2B, and 3A commons, the minimum cutting is 3 inches by 2 feet. 3B common admits pieces that yield cuttings not less than 1½ inch wide and not containing less than 36 square inches. For example, 4 inches by 9 inches or 3 inches by 12 inches. Now, let's take a look at the number of cuttings permitted in each grade. We use the following formulas, dropping fractions. In FAS, FAS1 face, and Select face, we divide the SM of a piece by 4. Example, 6 divided by 4 equals 1.5 yields 1 cutting. Pieces 6 to 15 SM will admit 1 additional cutting. However, initial yield will increase from 83 1/3% to 91 2/3% for 11 units per SM. In 1 common, we add 1 to the SM and divide by 3. Example, 6 plus 1 divided by 3 equals 7/3 equals 2.3 yields 2 cuttings. Pieces 3 to 10 SM will admit 1 additional cutting if yield is 75% clear face rather than 66 2/3% and factor is 9 rather than 8. In 2A and 2B commons, divide the SM by 2. Example, 6 divided by 2 equals 3 cuttings. Pieces 2 to 7 SM will admit 1 additional cutting if yield is 66 2/3% rather than 50% and factor is 8. In 3A and 3B commons, there is no limit to the number of cuttings. 97% rule in FAS, FAS1 face, and Select face. A piece having cuttings less than 5 feet long will be graded FAS if the following provisions are respected. The piece should be 6 inches and wider. It should be 6 to 12 sm. A maximum of 2 clear cuttings, full width, no matter the length, but not exceeding 5 feet, 97% clear, or 11.64 units per sm. Limiting provisions include unsound wood. Within the first linear foot of a piece, there should not be more than 25% of unsound wood. Otherwise, face will be graded 1 common. To determine this percentage, bring the surface of defect into a square representing 25% of the first linear foot. Limiting provisions include wane. Wane is permitted if it does not exceed 1/2 the length of the piece. Otherwise, the face will grade 1 common. In addition, edges are independent from each other. The lengths of wane occurrences on a same edge are added up. However, there is no limit to wane width. Limiting provisions also include splits. Within the first foot, there is no limit to length. Outside or exceeding the first foot, length is limited to 2 times the sm. Example, 2 times 9 sm equals 18 inches long. All the splits outside or exceeding the first foot are added up. Limiting provisions also apply to pith, knots, and holes, but are rarely taken into account. A piece graded FAS 1 face should have the following dimensions: 8 feet to 16 feet long, 6 inches and wider, all thicknesses. A piece graded Select should have the following dimensions: 6 feet to 16 feet long, 4 inches and wider, all thicknesses. On the best face, this grade requires FAS yield. The faces are independent from each other. On the reverse, the grade requires 1 common minimum yield. Wane will be limited on both grading face and reverse. To determine the width of wane on one common face, the largest width on one edge is added to the largest width on the other edge. The sum should not exceed 1/3 the width of the piece. For example, wane is 1 3/4 of an inch wide in the piece. 1/3 of 8 inches equals 2 2/3 of an inch, or plus or minus 2 5/8 of an inch. Here, wane does not exceed 1/3 the width of the piece. For pieces 6 inches and wider, the lengths on each edge are independent from each other. The occurrences of wane on the same edge are added up without exceeding 1/2 the length of the piece. For pieces 4 inches and 5 inches wide, the lengths on each edge are added up. The occurrences of wane on both edges are added up, and the sum should not exceed 1/2 the length of the piece. As for the width, the widest portions of wane on each edge are added up without exceeding 1/3 the width of the piece. When grading a piece, it may be necessary to separate sapwood from heartwood. Let's see what the difference is. Under the bark, there is sapwood, which is the clearest part of the tree. In maple and birch, sapwood is called sap. Then, under sapwood, there is heartwood, or duramen. In maple, it is called brown or regular, and in birch, red or regular. Pith is in the center. Now let's have a closer look at sapwood. Once grade, FAS, Select, or 1 common is determined, sapwood or sap should be found on at least one face of each cutting. Even though there is a small amount of heartwood in the cutting, the minimum required number of units should be white and clear to be graded sap. There may be a mixture of color on one of the cutting's grading face. In that case, the color may be found on the other face, but the cutting should be clear instead of sound. Pieces graded FAS and FAS 1 face sap should be at least 5 inches wide rather than 6 inches, according to some specifications. There is no limit to mineral streaks in sap, but the tendency is to reject them as often as possible. In the case of red birch, the grading procedure is the same as sap, except that cuttings should be red. The color specifications related to this category apply to hard maple. For one white maple, both faces and both edges of cuttings should be white. The 2 white grade requires a piece to be white on one face and both edges of cuttings. The reverse should be at least 50% white. For a piece graded FAS and FAS 1 face, 1 and 2 white, the minimum width of pieces should be 4 inches and wider rather than 6 inches according to some specifications. Also, limiting provisions apply to mineral streaks. See NLGA standard grading rules. Take note that SAP and better orders will include pieces graded SAP 1 white and 2 white. On the other hand, 1 and 2 white orders will include no SAP pieces. Regular or brown maple orders will not include SAP pieces, as cuttings are not from sapwood but mixed with heartwood on both faces instead. Orders where colors are unselected imply that color selection does not matter. A same order can thus include sap maple, 1 and 2 white maple, and brown or regular maple. However, unselected specification especially applies to birch. In Quebec, processing plants are provided with highly computerized drying equipment. Checks and warps caused by kiln drying are considered as defects. They will be permitted unless they disappear at minimum planed thickness. Rough kiln-dried lumber, specified 3/8 of an inch to 1 3/4 of an inch thick, may be 1/16 of an inch scant of the nominal thickness. Quartered lumber 2 inches and thicker may be 1/8 of an inch scant. The minimum widths mentioned in all grades, FAS 6 inches, Select 4 inches, and Common 3 inches, may be 1/4 of an inch scant in width. The small widths can be added to the 1/4 of an inch already applied to green and or air-dried lumber. In short, a piece with a minimum width as FAS is acceptable at a minimum width of 5 1/4 of an inch for 10% of shipment. However, it will be accepted at 5 3/4 of an inch with no limited volume. The original official inspection should result in not more than 4% deductible difference in money value from the gross amount of the invoice. See for details in the NHLA inspection regulations. Quebec lumber offers a great deal of possibilities to its users. Our winters and slow growing of our trees provide it with unique characteristics resulting in finer grain and increased strength. Whether specialized in furniture manufacturing or other wood products, manufacturing companies appreciate these particular advantages. Known for its considerable strength, Quebec lumber goes beyond all selection requirements. Hardwood is a priceless resource. Its warmth and beauty are part of your daily life. Quebec lumber has been thoroughly tried and tested worldwide through multiple applications, including the most common, such as wood furniture, floor, molding, and panel manufacturing. Many customers throughout the world rely on Quebec wood products for their exceptional appearance and strength. Quebec sawmills offer you an extensive variety of species and grades. Thanks to the quality of our resource and the accuracy of our classification standards, you'll find the product that meets your requirements. A product with unique characteristics that improve the quality of your production. Quebec lumber, trusted for its reliability.